Welcome to Solutions in the AM. That's our new unit in chemistry. And we're going to start with a few notes here. On the screen, there we go. And you're not going to write everything down. I'm going to read through it because we don't have a textbook. But Solutions unit. What we're looking at is the word dissociation. I used it the other day, but I didn't use the word ionization. And then dissolving too. So what you need to actually write down is ionic substances. It's in bold. Well, yeah, I'll give you a chance to write this down. Okay. This is what you're writing down in one ionic substance containing a metal or the ammonium ion, NH4+. And then the underlying parts. Okay. Pause the video, you can jot that down. Okay, you got these things copied down. Pat it up the bottom. So you copy down ionic substances. They have a metal and then a non-metal. That's the quick way to identify it. It's always got a cation and an anion, with one exception, that's the acid. Ionic substances are composed of positive and negative ions. We call those cations and anions. Arrhenius was a scientist, and Arrhenius proposed that ionic substances come apart when they enter solution in water. These ions are free to move about the solution. We call this process dissociation. It's different than dissolving. At home, if you put table salt into water, you probably just say dissolve. That's fine. It's a little more particular in chemistry. Here's calcium chloride in this example. And you notice I have it as solid. Now you don't actually say plus water. We know it's in water because of this symbol, aqueous. So last unit, this unit, and the next unit, we're going to be careful and actually make sure we have the little acids or the and the elements. Usually you can just ignore them. In the previous course, probably. But anyways, it's important here. I'll be a jerk and take off marks if we don't include it. So, calcium chloride. It breaks up into its two ions, calcium ions, chloride ions. You notice it's properly balanced. Cl2, so that means 2 Cl negative. Does that make sense? Okay. So once it's in water, it's not little units of CaCl2 floating around in the water. It's units of positive cation and the negative anion floating around in the water. And maybe in grade 10, that was the Quinn system, so you probably didn't have time to do this there. But if it's in water, pure water, pure water should not actually conduct electricity. This is something I always do in grade 10 science when I taught it. And did you guys do an experiment with conductors? Simply just a little battery and a meter? Okay, didn't do the experiment. Anyway, pure water should not conduct electricity. However, it's very practical, like on a lake and stuff. It's not pure water. It's got other things dissolved. If it's got an ionic substance, sodium chloride or calcium chloride or whatever. I keep using sodium chloride because it's the most common ionic substance in your house, probably, right? That you're aware of. There's others. Anyways, if it's in water, that means there's a bunch of positives and negatives floating around. It will conduct electricity quite well. Okay? So if lightning strikes on a lake, if it was actually H2O, 100%, no impurities, I wouldn't say you're safe because there's a small element of like risk or whatever here. But the fact is that lakes are never pure water. But it shouldn't, if it was pure water, it should not conduct electricity if lightning strikes. However, on a lake, it's not usually the water. Now, the other thing, okay, so ionic substances like salts themselves. Dissociation is a better word than dissolve. It separates into ions. Acids also have a positive and a negative, but the positive is hydrogen. So I asked you to write down acids containing a non-metal with hydrogen written first in form, H plus. Now, certain molecular substances also form mobile ions when placed in solutions. Arrhenius proposed that acids, when placed in solution, form mobile ions. Movable, right? The cation is the H plus in the other one. He called this ionization. So really it's the same as dissociation. But when it separates, we call it ionization. So there's an example. H2SO4, that's called sulfuric acid. If you remove one H plus in water, now it's acidic. That's what makes water acidic, because the H plus is released. More about that next. Jot that down. Okay, I'll give you guys a moment. I'm recording here to jot down the rest of the underlying materials, sentences. So what I had you write down is, in both cases, dissociation and ionization. The end result is movable ions, mobile ions in solution. Thus, since ions are present and can move, both acids and ionic substances conduct electricity, and they're termed electrolytes, right? You ever heard the term electrolytes? If you're sick and you have to drink something, yeah, you're actually increasing some ions in your system, those drinks. Yeah. Molecular substances, the third type, only non-metals as far as we're concerned. Oh, molecular substances that are not acids, on the other hand, do not ionize nor dissociate. They don't come apart. They don't form ions in solution because molecular substances are not formed with ions. Therefore, these substances do not conduct electricity. They're non-electrolytes. An example is given below. From left to right, all you do is CO2 gas, arrow, CO2 aqueous. Still, there's nothing to do other than change G or S to AQ. Yeah, we talked about this process. CO2 gas in water, what do we call that commonly? Okay, and what kind of, where do you guys see this quite common too? In a can. What do you guys, CO2 dissolved in a liquid? What do you call that drink? Soda pop. Yeah, carbonated beverages, right? So gases can dissolve, solids can dissolve. You can say a liquid can dissolve in water too, right? You can add it. Okay. They're very easy formulas. Okay. We'll copy this out, but we're going to go through an example in a second. Writing dissolving reactions. First thing you have to do is figure out, is your reactant ionic, acid, or molecular compound? As far as acids, other than H2O water, we'll just assume that if I give you something that starts with an H, HCl, chloric acid, H2SO4, sulfuric acid, H something, it's an acid. Right now, that's a simple definition. And then, if it's ionic or an acid, you're going to write out the aqueous ions that form it. And rewrite the substances in aqueous form for molecular substance. Just rewrite it and put AQ in balance if needed. Okay, we're going to do 3 examples together right now. So we'll do one at a time. I'll just pull it up. Writing a dissolving reaction. So jot this down and we'll start. You might need that periodic table handout set that I gave you at the start of the year. It has an ion sheet on it. You might need it. You know, it's up there. Why not? But I would suggest you get it up. Yeah, I'll just place it. The last page, if you flip it over, second, is your chart of ions. Periodic table of ions, right? How's that hand? Okay, look at this. The first thing I want to do is, now look, the first thing is not H, so it's definitely not an acid, right? started H3 PO4. It is. Sodium or metal, is it on the left side of the periodic table? Yeah, it is. Sodium is a metal. So if it's a metal, and then PO4 stuff is not, that's an polyatomic. What do we call this? Molecular? Is it ionic? Or is it an acid? Determine this. Well, let's get back then. Ionic substances in the metal or ammonium iodide, which is not. Acids start with H. Moleculars are only done. We know it's not molecular. Back to where we were. It's got to be ionic. So the simple stuff we're doing, if it starts with a metal, it's going to be ionic. I'm going to just put this here. I for ionic. Now I know the word dissociation is the best word. Now, we're calling this the solutions unit, but it's actually more of equilibrium. I'm going to put a double arrow here. Okay. We know why we talked about this before. Every time that an ion comes out of the solution, two ions bump in together and form a solid. So the first ion is the NAs. We've got three of them. The second one is the PO4. Now, PO4 comes as a group. How do you know that? Well, typically, these things that only break up into two. Don't know the charge of that. Look it up on your right. You see right there. Na is a plus. Put Na plus. Okay, Na plus, and I see that I have three of them. I'll hold off on it. It's going to be Ag. Plus, what's left over? PO4. I don't know the chart of PO4 actually. Don't. Scan here for the chart of ions, right? PO4, and I see that it is 3 minus. You notice where it is up here? I kind of have these organized by charge. Section. So PO4 would be 3 minus. That's 8 kilos. So we do the balancing. There's one group of PO4 on the left and the right. 3 and 8. Oh. Oh. I've written the dissolving. So 8 Q 8. That's really important. Now, the next one, we'll talk about it. C6H12O6. Any metals present? Biology people, do you recognize this? Yeah, glucose, okay. Yeah, it's definitely molecular. The H isn't at the start, so it's not an acid. It's sugar, glucose, it's a type of sugar. So, I'm going to put M for molecule. Identify it, whether you're explicitly asked to identify it, or you just need to think this through. That means I just rewrite it. This is the easiest thing. I won't have 20 of these. Just write it down and say it's dissolved. And I have it back and forth because, as you know, actually the sugar that you guys table sugar, because it's not sucrose. But anyways, it'll sit at the bottom of the glass and you put when you saturated the solution, it'll go back and forth out of equilibrium or out of dissolved in water. The proper term for this is dissolving. Back and forth between solid and liquid. Okay, the last one, finally an acid. It starts with an A. It's the same as dissociation, but we use the word ionization. It separates into its ions. Now, this one's only one H at the start, but even if it was, remember, H2SO4 or H3PO4 or something, just take one H off. Leave the others behind. More about that later. That's H plus. And you'll use hydrogen enough that I don't need that. So take off a positive, the NO3 is left over. It must be a negative. But if you didn't understand that, you look up NO3 on the ion chart, you say, oh, it's called nitric. Like nitric acid. But anyway, it's that. There you go. For those of you working from home, hopefully you understand this. I want you, I'll just peel these out just so the people at home can see them all on the screen. You guys have them all on the sheet. Work away at these. Write the dissolving reactions just like we did for each of the following. And there's two things you want to do for each. And then identify if they're acid, ionic, or molecular. Just do what we did with the I, the M, or the acid, right? M or the I, or the A, the acid. Right? Anyways, decide like you did, and then write out the reaction. Like for example, the very first one, carbon monoxide. That's actually really double arrow. Oh, what is this? Molecular, ionic, or what? Think of a staircase on the periodic table, like up by 5 long. Anything up in that corner is non-metal. E and L are both non-metal. Molecular. So I just say, put an M there beside the number 1 or something like that on either side. And then this is just CO. Carbon monoxide, well, you wouldn't want to drink that. Carbon dioxide, delicious. Carbon monoxide, kill you. Okay, we're going to go through these and separate things into their ions, etc., if necessary. Do that with the other 9. I'm going to pause the video. Okay, on the video here, pause this, finish these questions. Okay, I'm assuming you've finished the questions now. I'm going to just show the answers on the video. Okay. So this is what you should have had. Here's the solutions. Slowly scroll up to C9 and 10. I showed number 10 2 ways. The first way is the better way. Okay. Obviously, pause. Take a look at what you need to. Over and out. See you later.